Hello everyone, in this recording I will talk about the instantaneous center of zero velocity. So this is an important concept in kinematics of a rigid body. So first let's start with the wheel example. So in a wheel, we are generally considering that there is no slip. Okay, and there is a point that has zero velocity. So it means that there is a point that doesn't move. So for example, the point that is in contact with the ground, it doesn't move. There is a point that has a velocity equal to v, and there is a point that has twice velocity. So these are the... Okay, so let's first analyze this motion, and then we will talk about what is instantaneous center of zero velocity. So this is the general motion of a wheel. So it rotates as well as moves forward. Then wheel, no slip. And then for this wheel, we can consider the pure translation. And then we can look for pure rotation. And then if you remember, we have said that for a rigid body, let me show it for you. For a rigid body, if it translates, the whole particles move with the same velocity. Then similar things will happen here. For this wheel, all the fluid particles will move with a velocity of v. So it will move with velocity v, and then we have everywhere the velocity of v. And this v is omega into r. Okay. Anyway, so we have a velocity of v everywhere in this translation of the wheel. And as well as we have a rotation of the wheel. And then rotation is, so wheel rotates this way. So it has a omega r, and then it has the omega r, and then it has omega r. This way the wheel rotates and then as well as translates. If I look for point, say that here, for this point, and then for this point we will have the v due to translation, and then we will also have the omega r. Okay, so what it means is that we have the velocity of 2v. Okay, because this v is same as the omega r. So that v is same as omega r. Okay. But if I look at the bottom part here, so here I have a velocity v, but I also have the omega r. We use a different color. And then at this point, then we have a zero velocity. But if I look at another point here, so that for this point, again here I will have a velocity v, and then I also have the omega r, which is the tangential velocity that is downwards, this way. That is omega into r. But if I look for the resultant velocity, that will be something like this one. Or I can check another point here, so that will have a, for example, the point here, it will have a v, and it also have the omega r. Okay, and then for this point as well, we will have a resultant velocity of the v. As you can notice that we have a zero velocity here, but everywhere we have a different types of the velocities. So, but the important thing is that this point is a perpendicular to that one. So this one is perpendicular to that one. So we have another point that is, okay. So if you look at it here, so we have an instantaneous center here. So this is instantaneous center of a zero velocity, and the rest is having a velocity. So you can say that now the wheel is like rotating around instantaneous center. Okay, it's like this one has a zero velocity. The whole wheel is like rotating around this center. At this center, the instantaneous, we have to notice is that at that instant the velocity is zero. It is not that velocity is always zero there, but it is the at that instant, whenever the point is in contact with the ground, that has zero velocity. But this one again, I should say that there is no slip. If the wheel slips, like if there is an ice, then the instantaneous center will not have a zero velocity. Okay, so this is what we mean by the instantaneous center of zero velocity. For any geometry, we can draw an imaginary line that it shows that the point rotates around that instantaneous center. Okay, it is like, for example, this is the point A, and then it is like that this point A rotates around this instantaneous center. Okay, it's like it draws a circular motion around this center, and this center has a velocity of 0. You see, the velocity at this center is 0. This is imaginary. Or we can do the similar stuff here. So we have 2 points A and B. Again, we can draw an instantaneous center such that these two bodies is as if like rotates around this instantaneous center. Okay. Or we can